Simplifying radicals. First of all, let's review what a radical is. A radical is just like a square root, so something like this. And let's talk about a square root. If I have 9 in there, the square root of 9 is 3. And that's because 3 times 3 equals 9. What about the square root of 25? 5. Because 5 times 5 equals 25. What about square root of 100? 10. Because 10 times 10 equals 100. So these are all called perfect squares, and that's because it's a whole number times itself in order to get back to the number that's under the radical. Today we're going to work with non-perfect radicals. Here's an example. What if I told you square root 18? We're stuck because we can't find the two numbers that multiply to be 18. These numbers have to be the same. So if you look back down here, 3 and 3, 5 and 5, 10 and 10. There's no two numbers that are exactly the same that are going to give you 18. Some of you might be thinking 9. If this was 9 and this was 9, that would mean 9 times 9, and that's actually 81. You are correct that 9 plus 9 is 18, but we are using multiplication when calculating radicals. All right, moving on. The first one we have is square root of 96. So in the past, when we've had an answer like this, we've always just picked up the calculator and we've typed in square root 96. That gives us a decimal answer, and today we do not want decimal answers. We want to get exact answers. Here's how you find an exact answer. So what we're going to do is we are going to break down this radical, and we're going to use what's called a factor tree. A factor tree is coming up with numbers that multiply to be that number. So for example, if I did 2, I'm trying to figure out 2 times what number equals 96. I'm going to use my calculator, and I'm just going to do 96 divided by 2, and I get 48. And so what I've just said is that 2 times 48 is 96. Now you are going to continue to break down this tree, but the only numbers that you can break down are numbers that are not prime. So for example, if I tried to break down this 2, the only multiplication to get 2 would be 2 times 1. You cannot use ones in a factor tree. Okay, I'll give you a little note over there. No ones. So right here where I did 2 times 1, this doesn't work because 2 is prime. So going back, I'm going to erase this. We're done at the 2. Now we're working on the 48. I'm going to say 6 times 8. If you came up with a different multiplication to get 48, that's totally fine. If I break up 6, I'm going to try 2 and 3. I'm going to break up 8 with 2 times 4. And I'm going to break up 4 with 2 times 2. Now, I can't break up a 2 because that will only be 2 times 1. Can't break up a 2. A 3. If I try to break up a 3, the only multiplication is 3 times 1. That doesn't work. So now that we've broken down everything, I like to kind of cross out the ones that have been broken down. 48's been broken down, 6 has been broken down, 8 has been broken down, 4 has been broken down. We're only looking at the numbers that have not been broken down. So for example, the 2, the 2, the 3, the 2, the 2, and the 2 are the only numbers who have not been broken down. Now we are looking to get them in groups of 2, and they have to be a match in order to make a group. So for example, these 2's are a group. These 2's make a group. Now I'm looking at this 3. I do not have another 3 to make a group. So what happens is that 3 doesn't get a group. So I'm going to put a square around the 3. We have another 2 that does not have a group. So I'm going to put a square around that 2. Here is how we write our answer. Out front, we put the groups. And underneath the radical, we put the squares. If you have multiple terms, then you would use multiplication. So for example, I have a group of 2 and I have another group of 2. And so those would go out front. A group of 2, another group of 2. And when you have multiple groups, you would multiply the number. And inside the squares, we have a 3 and a 2. So a 3 and a 2, and I would multiply. So now to simplify, out front we have 2 times 2, which is 4. And under the radical we have 3 times 2, which is 6. So this answer is 4 square root 6. Now what you've just done is simplified the radical. In the past you have always simplified fractions. This is the same type of work. You are just simplifying the radical. Okay, let's try another one. We have square root 72. In the past we've just plugged this in the calculator and we've got a decimal. Today we want no decimals. We want everything to be a simplified radical. So I'm going to break this down, and you can pick whatever 2 numbers you want that multiply to be 72, but the first ones that came to my mind were 8 and 9. So I'm going to break down 8, 2 times 4. I'm going to break down 4, 2 times 2. Now I'm going to break down the 9, 3 times 3. And I want to kind of not look at all of the things that have been broken down. 8's been broken down, 4's been broken down, 9's been broken down. And I need to check what's left. I can't break down a 2 because that would be 2 times 1 and we can't have prime numbers, which means we can't multiply by 1. 2, 2, 3 is a prime number because the only thing I can do is 3 times 1. So all of these numbers left over, 2, 2, 2, 3, and 3, are the numbers that are prime and can't be broken down. And our goal is to get them in groups of 2. So I have a group of 3's, I have a group of 2's, and I have a 2 that does not have a group. So I put that 2 in a square. I actually like to do a different color. And the way we write our answer is the groups go outside, and in the square we have the square. And here's how I remember it. This is called the square root. And so the square numbers go in the square root. I've also heard it as a little dating scenario. Oh, this 2 and this 2 have a date. They can go out. The 3 and the 3 have a date. They can go out. And when I say out, I'm saying go out of the square. This poor little 2 didn't have a date, so he's going to have to stay in the square. So our answer would look like this. We have a group of 2. We have another group of 3. And if we have multiple groups, we multiply. In the square stuck is a 2. Poor little 2. So our answer, 2 times 3 is 6. In the square is 2. So this simplified radical is 6 square root 2. Okay, we have a big number, 343. We have to come up with 2 numbers that can multiply to be 343. I usually start small if I don't know. So I'm going to start with, I can't use 1s because they can't go in factor tree. I'll start with 2. Well, 2 cannot go in this number because it's odd. If I do 343 divided by 2, I'm going to get a decimal. I tried 3 in my calculator, it didn't work. I tried 4, I tried 5, I tried 6. And when I say I tried, what I'm doing is I'm using division. So for example, in my calculator, I just typed 343 divided by 7, and it equaled 49. So what that means is that 7 times 49 would equal 343. So I'm going to use that one. 7 times 49. Now I'm going to break down my 7, and I'm trying to think what 2 numbers multiply to be 7. Well, 1 times 7 does, and that's the only thing. And that means that I can't do that because 7 is prime. So 7 is done. So now I try 49, and 7 times 7 is 49. And now those are both 7s and can't be broken down. I like to kind of cross out the numbers that have been broken down so that they don't confuse me. And remember, my answer, the groups go out front, and the squares have to stay home in the house, in the square root. So I have a group of 7. There's a group. And I have a poor 7 who's stuck in the house. A 7 that's stuck in the house. So the answer to this would be 7 square root 6. That is what 343, the square root, reduces to. Oh, this one's a little different. You should notice that you have a 10 out front. We're going to ignore the 10 for just a minute. I like to kind of just draw an arrow from the 10 so I don't forget about it, because we're not going to use it until the very, very end. So going on like normal, we're going to break down what's in the radical. 96, and this actually was the very first question we did, square root of 96. And so I'm going to use the same numbers. We did 2 times 48, and then we did 6 times 8, and then we did 2 times 3, and then 2 times 4, and then 2 times 2. And I'm going to black out the ones that are all broken down. Broken down, broken down, broken down, broken down. And I'm going to check all of these that aren't broken down to make sure they're prime. 2 times 1, 2 times 1, 3 times 1, 2 times 1, 2 times... Yep, those are all prime. They can't be broken down. So now I'm finding my groups. I have a group of 2s. I have a group of 2s. And sadly, this 3 doesn't have another 3. And this 2 doesn't have another 2. And so to write this out, remember my answer goes groups and squares. And so I have a group of 2. I have another group of 2, and so they will multiply. And stuck inside the square, I have a 3 and a 2. So this would give us 4 square root. 3 times 2 is 6. And if you remember, we were saying that at the very end we would bring this 10. The 10 is outside of the radical, so the 10 needs to go outside of the radical. And what you're going to do is multiply the 10 by what else is outside. So 10 times 4 is 40, and then in the square we have 6. So 40 square root of 6 is the reduced version of 10 square root of 96. Okay, 7 square root 600. So we ignore the 7 until the very end, and we're going to break down the 600. So I'm going to start out with just saying 6 times 100. Then I'm going to break down my 6, 2 times 3. And hopefully you're recognizing 2 is prime, 3 is prime. They cannot be broken down. Now I'm going over to 100. I'm going to say 10 times 10. And then break down 10, 2 times 5. Break down 10, 2 times 5. And 2 can't be broken down. 5 times 1. Nope, 5 is prime. 2, 5. So I'm stuck. Everything cannot be broken down. I like to kind of cross these out so they don't screw me up. And I'm looking for groups, because my answer is going to be groups outside and squares inside. Now, my circles are going to look a little funky here, but I have a group of 5s. I also have a group of 2s. Then unfortunately this 2 and this 3 do not have a group. So moving on, my groups go out front. I have a group of 2. I have a group of 5. If we have multiple groups, we multiply. The squares, I have a group. I don't have a group. I just have a 2 and I just have a 3. And so my answer, 2 times 5 is 10. Square root 2 times 3 is 6. But we are not done, because we still have this 7 outside of the radical. So I bring down the 7, place it outside of the radical, and it multiplies by what is already there. 7 times 10 is 70, and then square root 6. So 7 square root 600 is reduced to now 70 square root 6. 9 square root 125. Bring the 9 down at the end. Okay, 125. I'm thinking of quarters. And let's see, how many quarters are in $1.25? 5 of them. So there's 5 quarters. 5 times 25 is 125. 5 is prime. It can't be broken down. Okay, 5 times 5 is 25. 5 and 5 can't be broken down. I like to cross off the numbers that have been broken down. I have a group of 5, and I have a 5 without a group. And so my answer groups go out front, squares stay in the squares. So this would be a group of 5 and a 5 that's stuck in the square. And we are bringing down the 9 that's in front of the radical, and we multiply. 9 times 5 is 45, square root of 5. So 9 square root 125 reduces to 45 square root 5. Holy crap, this is a big one. I'm reminding myself not to forget about the 12. So 1764, wow, 1764. I have no idea, so I'm just going to start with 2. Because this is an even number, 2 will go into it. So in my calculator, I'm typing 1764 divided by 2. And that gives us 882. And then I can't break down 2 because it's prime. And I'm going to break down 882. Well, 2 goes into there. And it goes in there 441. Oh, wow, 441, that's a big number. 2 can't go into 441 because it's not even, so I'm going to try 3. So in my calculator, I'm typing 441 divided by 3. And I get 147. So this would be 3 and 147. 2 can't go into 147 because it's not even, so I'm going to try 3. 147 divided by 3. And I get 49. So 3 times 49. And then 49, 7 times 7. And we should notice 2 is prime, 3 is prime, 3 is prime. Nothing multiplies to be 7 besides 1 in itself. So now I'm looking for my groups. Here's a group of 7. Here's a group of 3. Here's a group of... And oops, I made a mistake right here. If you look right here, when we did 8... No, that's right. That's a 2. I didn't make a mistake. I tricked you. Group of 2. Oh, wow. There are not any numbers that were stuck inside the square. So we have a group of 2, a group of 3, a group of 7 that all need to be multiplied together. And underneath the square, there is nothing. So if there's nothing underneath the square, you don't even have to write it. So we have 2 times 3, which is 6, and we still have times by 7. 6 times 7 is 42. And our 12 we can't forget about, that's up here. So I bring it down and it multiplies. So in my calculator, I'm figuring out 12 times 42. And that gives us 504. So you'll notice that this radical, from the very beginning, when we simplified it, it didn't have a radical. That's because 1764 is a perfect square. And we got 42. So that means that 42 times 42 is 1764. It's a perfect square. Okay, last one. I'm breaking down 2535. I am using the wrong color. So I know 5 can go in here because it ends in a 5, and that's one of the divisibility rules with 5s. So in my calculator, I am going to type 2535 divided by 5. And I'm getting 507. And now I need to break down 507. I know 2 can't go in there because it's not even. So I'm going to try 507 divided by 3. And I get 169. 3 and 169. Now, 13 times 13 is 169. So here I cannot break down 13 because 13 is prime. The only thing it breaks down to be is 1 times 13. So we have a group of 13, a 3 without a group, and a 5 without a group. So my answer, the group goes out front, and inside the radical I have the squares, so 5 times 3. And I have to remember if there's a number out front to bring it down. So now I have a 7 times 13, and in the radical I have a 5 times a 3. Well, 7 times 13 is 91, and then under the radical I have 15, And so this is my simplified radical. Now you're going to get to your assignment, and these 8 questions that we just did are all on the assignment. So you have 8 of them that I've already helped you do. Still try them, but you can use the video to help you complete them. Good luck and have a good day.